Hello,
Yes.
everybody. If you were here on Friday, I gave a fun talk with a bunch of pictures of fire, kind of motivating things a little bit better. This will be not less fun, but more detailed, so it'll be a bit drier. But I'm excited about this one. We're going to dig into how PDP works and what the programmable hooks look like. So Arsh gave a really good example. He's been building stuff that actually uses these hooks. So we're going to get into the architecture there, see how everything fits together, and by the end, you should have a pretty good understanding of the sort of thing that you'll have to do if you want to write extensible programs that make use of PDP. And if you just want to understand how the system works better, this talk will also be for you. Okay, so here's the overall system architecture. You can kind of think of it in four parts. So we have a data client that provides files to somebody, and right now that somebody is typically Curio Storage. They've built out a wonderful PDP SP software, which will take in data from clients and prove it to the chain. And then you have the contracts, which is really the heart of the system. So there are two contracts, and we'll get into that a little bit later. There's the listener, which does the programmable hooks, and there's the verifier, which is the core of the system, which is processing proofs, and which is the thing that's interacted with by the SP software. Okay, so and then the last thing is something that's observing. So this is potentially optional depending on how you structure things. Today, the observer is an important piece of the system, and we've built the PDP Explorer so that you can check up on things. So this lets you understand what's happened with your storage on chain. So you can see there's like a proving heat map that's like a nice visualization of how good or bad things are. There's a way to, because the everything is done through EVM smart contracts with events, you can look at the events and you can say, okay, like how are things working on time? Like has my storage been proven? And you can do this natural auditing, which is a key part of PDP because, as we've been talking about in the comments in the chat earlier, the main value add of PDP is that it is the centralized verifiable storage. So you want to be able to check up on things. So this is the main flow. This is like we'll be seeing remixes of this architecture diagram throughout the talk. This is like the real thing to remember: client to SP to verifying contract to observer. And it really looks a lot like POREP if you think about it. It's very similar to this is really just the Filecoin storage model, but done in a way which makes things simpler to use in a lot of ways at the cost of it needing to be done between two parties rather than verified by a decentralized block rewarding system. Okay, so on to the next slide. So we'll break into how the verifier works in just a tiny bit. This is like these next two slides are probably some of the most important ones to understand if you really want to understand the system. So they are actually pretty simple contracts when it comes down to it. The PDP verifier, this is the thing which validates proofs. And yeah, I guess that's the main thing it does. It validates proofs. So as Arsh was talking about a little, the internal data structure of the PDP verifier are these things called proof sets. So you can think of each proof set almost like it's its own minor actor if you're familiar with POREP, or if you're not, then you can think of each proof set as a data set, which is agreed upon to be stored between a client and a provider. So there's no payment happening inside the verifier. This is just for proof validation, but we keep track of these independent sets of data. So a proof set, you can see the top level row. There are a bunch of roots. Each one of these roots is COMP. It's a CID, so it's a Filecoin native hash, which points to a Merkle tree of data. And so you have a big array of all of these Merkle trees of data. And there's also some metadata, including the sizes and index thing, which allow us to do proofs efficiently. Basically, you need to like randomly select some data anywhere in the roots and then prove it as part of the proving process. And so there's a bunch of metadata which helps with that. Proof sets also have some like constant size data. So the challenge epoch, which you can see on the right, that's something which is used for knowing when to sample randomness so we can get these good verifiable decentralized proofs. And two important pieces on the left there are these addresses. So one is an owner address. Again, very similar to the minor actor. This thing is externally owned and only the SP can be sending messages to it. So we validate that things are coming from the right party. And then the interesting one, which calls back to Arsh's talk, and we'll get into in the second part of this talk, is the listener. So this is how you program this verifier. We're using a model that we figured out over time that we would have liked to have done POREP with, basically like the DDO model, but we're really wrapping it up properly this time. So this thing is launched with the ability to call into a listener. So the listener is an address which you can call to, which the contract, in fact, will always call to inform state updates to the verifier, which allows a really nice programmable model for things. So yeah, really the whole thing of the verifier is a bunch of proof sets and some addresses for basically receiving and sending, and some metadata for making sure that proving happens right. Okay. So today on mainnet, we have launched the basic PDP, and for our first expected users, on-ramps, the thing that we want is a pretty simple programmable hook, which we're calling the simple PDP service. And all this does is it makes sure that we prove things within the right deadline. So it's quite simple. Arsh's talk was about a different listener contract. Again, we'll get to that a little later. And we'll dive into this one a little bit more later, but basically know that there's a second contract which is currently being used to keep track of how well the verifier is proving the different proof sets that you see when you go to like the PDP Explorer. Okay, so here's like the flow. We're going to go through just how like the life cycle of data on PDP. So in order to get started, you need to initialize a proof set. And so the SP software will call into the chain and it will call create proof set. The verifier will hear about it and it will go back into its data, create a proof set. It also informs the listener, and then the listener submits an event to the chain, and then observers can listen to the event and say, okay, great, we have a new proof set, and then display that sort of thing. When it comes to actually storing, so this is where we need to do some data transfer. So the data client sends data to the SP. Then we go to the SP will call a method on the verifier, which adds the roots into a proof set. So this basically appends to that array, which we were looking at before. This adds a root. Again, information gets propagated to the observer through an event. And now once you've added a root, then it's time to like prove the roots are like, now they must be proven. They're available to be proven. So you need to prove over this data. And yeah, this happens very much again, like ProRep, just like submit window post is not happening based on user triggered inputs. This is all triggered by time. So proof possession happens at a certain time, or it must happen within a certain window. And the SP software just does this for you. And then the observer can watch events happening and make sure that proofs have happened. Like this morning, I was checking to make sure that my mainnet SP is working right. And I just looked at the Explorer and saw, okay, like last night at 10 p.m., we had a proof possession. So I was like happy because it means that everything's working. This happens today. The configuration is once a day, but we'll get into, you can tweak that a bit as well. Okay. And in general, observing, like you figured it out. Like what happens is we send a message to the contract to do something, to make some sort of mutation to state, to keep track of things, and then this event gets propagated to to some observer, and that's the general way things work. It's pretty simple, pretty standard EVM stuff. Okay, but just a minor or maybe not minor. It's like something to keep in mind is that so the contract is the core of the system. It does the other pieces are great, but they don't need to be the same. So working with Sriracha, there's some efforts to make things which maybe fit into their stack a little bit more nicely, or maybe are like a little bit simpler for people to get started with. Not sure where that will end up, but there's some software being developed that would replace the Curio SP with just the Sriracha SP, which is totally fine. It works perfectly great in the system. You just swap out SP software for something else, which goes and makes calls to the contracts and handles data. And yeah, that works totally fine too. And the same vein, I think Storage will likely be doing their own observability. They'll be making sure that the data added to contracts to the proof sets is what is expected, and we'll make sure that proofs are happening on time with some additional software that's not just the PDP Explorer. Because everything is done in this standard EVM way, you can just listen to events and you can write whatever software you want to do that sort of thing, to do auditing and just checking up on stuff. So yeah, you can plug things in. The contracts are the core of the system. Okay, so now onto the programmability part. So when it comes to programming, it's not really a big reveal. We talked about it a bunch, but the way that you do it is by writing a contract which implements an interface called the PDP listener. So the PDP verifier calls into something, which it knows as the listener. So this address that you see in the center of the bottom piece of the proof set data, the PDP verifier contract diagram, that's an address which gets called during all the PDP verifier operations as triggered by the SP off chain. And this calls into the listener. So when you program, you build your own service. This is the interface. So you create proof set, add roots, schedule removal, prove possession, next proving period. So these are all the data set mutations, adding and removing, and then all of the like I guess meta operations or the like management maintenance operations, prove possession, next proving period, and then also initialization. So the listener hears about all these things. It has an interface that looks like this. So you provide a proof set ID, you provide some call parameters which are specific to the call. Like for example, with add roots, you include the root data. For proof possession, you include the randomness seed. And then you pass in the ability, it's extensible. So you have some extra data that you can pass in, which ends up being useful. I believe Arsh has actually already used this in his instantiation. And then the output you get is an error or a no error. So there's no real output. There's just this one there's an error signal. So this allows you to do things like access control, where the listener can say, no, you can't do that operation, and you need to like wait until you can. So for example, you could do things like guarding deletions upon like certain things, like upon like having a signature this way. And yeah, that's we actually we use that error case a little bit in our current usage of the listener. Uh, yeah, so just quickly, the first application. So like this is not like theoretical in the existing PDP system that I've been showing and you've seen some demonstrations of and people are starting to use. We do use this programmable hook. So we use the simple PDP service to sit on the other side of this interface. And that's how we built it out. So we built some very simple but useful functionality with this. So basically, all of the timing stuff is being checked from within the listener right now. So we have in the current simple PDP system, you have a challenge window that's 60 epochs and a proving period that's 1 day, at least on mainnet. On CalibNet, we've shortened things up a little. And this lets you do things like there's a nice model for faulting where you can check to see that things are all good. And if there is a fault, you can emit an event and you can deal with multiple faults and you can have some flexibility in declaring your fault. So I guess all to say that like this has been used, this programmable pattern, and it works well enough to get us to this system behavior. So it's actually not a crazy step to start building with it yourself. Yeah. And like, yeah, this is what our picture looks like. You basically just check these two pieces of metadata to know when the deadline is, and you make sure that you're getting your proof at the right time. If not, then you can throw an error from the listener. But yeah, it's a good programming system, and yeah, so you could also build things with it. So there's plenty of ideas of things to build. There's really no shortage. Like one example is like a simple one is you can just fork the existing simple PDP service and give it a different proving frequency, which is what we did on calibration net to get like nice testing. And you can do things like instead of requiring 5 proofs for each proving period like we do now, then you could like ask for more. You could store historical faults, which is stuff that some people have wanted. These are like simple tweaks. But then like more powerful things, the previous talk, you can actually implement payments on the other side. Like for example, when you add a root, you require payments in order to actually like do the adding. And then you can do like slashing upon faulting or removal. Using the extra data field, you can sign as a client. You can like require from the listener that the client has signed for adding and removing roots. We could build little things like a repair gadget, which like lets you, if you delete from one proof set, like one listener can communicate with another and authorize payment for adding to another. So there's lots of like good things there. And then what we're really planning at Philoz to do is use this to build out like nice systems. So the plan for FWS is to do POREP integration inside of the listener by either hooking into proper DDO or a client contract from FO5. We can glue the two together and have one listener do storage guarantees, decentralized storage guarantees with on-chain payments for like both services. And another nice idea coming from watching Longface talk last week is you can do a cross-chain data bridge over PDP as well, just by plugging in the same sort of contract that you have for that with POREP into the PDP listener contract. So yeah, that's really it. I wanted everyone to know how to build with PDP. There's a couple forms here. Storing, there's a MinerX program. If you want to get involved with storing, it would be useful to get started that way. So you to have some help. Check out the PDP Explorer, both on CalibNet. If you put calibration dots in front of that, then you can see the CalibNet one. And then if you want to build some GitHub stuff and some Slack, check out Phil PDP, check out Phil FWS, obviously Phil Builders. We're available. We love talking about this stuff. Yeah, so that's everything. Thank you very much.